Just a moment, let me just load my slides. Okay, we can all see the slides.
Yes.
Yeah.
Yes.
Okay. All right, so we can start. Good afternoon, and sorry for the hiccup. I wasn't getting audio, but I think now we should be good. And I'd like to thank Dr. Wanjiku and the whole class for inviting me to this session. That will just be talking about IoT. We'll have two sessions. I'll have one this afternoon and another next week on Wednesday. So this afternoon, I'll just be doing a brief introduction to IoT and some of the scenarios that we are able to apply the IoT technology. So my name is Achik Cornelius. I am an engineer here at KENET. KENET is the Kenya Education Network, and we work closely with higher education institutions and research institutions on building ICT solutions. So I'll be taking us through just the introduction of IoT. I'm sure most of us have heard about IoT, but we'll now delve deeper and look at what can we implement, or what kind of projects can we do in the field of Internet of Things. Yeah, so as a start, what is IoT? IoT is an acronym for Internet of Things, and I am sure as a whole class we might have come across the term Internet of Things, and probably we've not looked at or explored exactly what it entails. So it refers to a network of connected devices, and I'll be referring to devices and things interchangeably during the course of this presentation. So basically, it's a network of connected devices or things that are integrated with sensors and have some software in it. And finally, that needs connectivity so that they're able to connect to the internet, so that you're able to collect data and do the rest of analysis of the data or whatever we want to do. So hence the name Internet of Things. So you have a thing which is a device that is running some software that connects to the internet. And the whole point is so that it's able to enable real-time data exchange. And also we should be able to automate decision making based on the data that we are going to collect and the analysis that is being done on the things or the devices. So the reason we are able to do or to run the Internet of Things ecosystem is because of a few technological advantages that we've undergone, I think, from the age of the internet, which is around from in the 90s, early 90s, up to today. So the most common thing about Internet of Things is that they are low cost and they require very minimal power. These sensors that we use to run Internet of Things ideally should be able to run on very low power for an extended duration of time. Let's say 5 to 10 years without replacement of either the battery or whatever power system that is powering the device. Second to that is we have really improved in terms of internet connectivity in globally, and I think also in terms of the African continent, we have really come from very far away. Nowadays, we get speeds of we get gigabit speeds even from our laptops, from our mobile devices. So leveraging on that high-speed connectivity, we should be able now to do Internet of Things and connect everything and anything that is able to communicate with the internet. And this is whether you are talking about your wearables, your watches, your fridges, your TVs, let's say any kind of sensor, that anything that is able to get an IP address and connect to the internet should ideally be able to work with the Internet of Things ecosystems. And then we have a blow up of cloud providers, and also technology wise, we have actually improved on the computational power of our devices, whether in the cloud or on our handsets. So, but in this case, when I talk about the cloud computing, this will be where we are going to require computing power for the data that we are going to be analyzing that has been collected from the IoT network. The other thing is machine learning and analytics. This one is so that we're able to get meaningful data in human readable form, and we're able to make decisions based on the kind of data that has been collected from the IoT devices or from the things that we are going to be having. And then the last one is conversational AI. This is through the breakthrough of AI, such that we are now able to communicate with AI in human language. Case example is when you're having your digital assistants, the Alexas, the Googles, the iPhones, and the likes, the Series. So based on that, we are now our devices are able to communicate in human form.
So Achiki, could I interrupt kindly?
Yes, Doctor.
So your slides are not transitioning. We're still on slide 1.
Yes, I'm actually going through the slide. Wait, we are still on IoT.
We're just seeing the title slide. Okay, now they've moved, yeah.
Now they've moved.
Yeah.
I was doing presentations, so yeah, I'm so sorry.
That's okay. No, it's okay.
This is what I was talking about. Huh?
Okay.
Yeah, so the advancements that we have, as I mentioned, we have low cost. So the sensors are quite cheap nowadays that you're able to buy, and also low power. I'm sure most will ask about our mobile phones and the rest about being powered, but this is more so especially if you are doing sensors in remote places, whereby you don't need to power them using, let's say, commercial power, or it just needs battery, a very small battery that is able to run for an extended duration of time, probably, as I said, 5 to 10 years. And then I mentioned internet connectivity, where we have made significant strides in having high capacity internet connectivity. Cloud computing, I think with the advancement of the chipsets and increasing of most cloud providers, I think right now we have so many, we are spoiled for choice. But mostly we know the major ones, which is the Amazon and the Googles and the Oracles that provide cloud computing. And then machine learning and analytics for analyzing our data so that we're able to get insights into what are we getting this data for, and what is the data telling us. And finally, as I mentioned, conversational AI with our digital assistants. Yes. So the key components of the Internet of Things systems. So you do have, there are 4, but there's one that is missing, which is called a gateway. So we have 5 components. We have the device, which is, let's say you have a sensor that you have installed. Think of the sensor as, in this case, I'll be using, let's say the fridge. I'll be using our fridge as our device or the sensor. And then we have something called a gateway that communicates with the sensor. So the gateway in this case will be like the wireless router in your house. So I hope we're getting the architecture. We have the fridge, we have the gateway, which communicates to the fridge on a certain protocol. And then the router has internet connectivity from the service provider that connects now to the cloud, which is now the data processing and the analysis. And then once that is analyzed, you have an interface that is able now to give that information in a simpler way to a user who is not technically gifted. So it can be either a mobile application, it can be a dashboard, a web dashboard, or any other system that has been integrated to a management system in an organization or just in your local environment. So there's a depiction here of the major components of the IoT. So we have the thing, which is the fridge, as you can see here. This is the fridge. And then we have the gateway, which is our router in our houses. And then we have the cloud. Probably this might be a local cloud or Amazon Web Services or the Google Cloud. And then we have the analytics, which is now the computing part, where you are running, let's say it's the GCP or the AWS computing platform that you're going to be using just to analyze the amount of data that has been read from the device. And then you have an application that is able to give a visual representation of the data that has been collected. So at the end of the slides, I'm going to show you some of the raw data that we collect from one of our sensors that explains why you need to have that kind of analysis, because it's a lot of jumbled data. So are we together?
Yes.
Okay, thank you. So we go to the next slide. So why do we need to have IoT right now? In the previous decade or two, most of the sensors that we had required human intervention so that you're able to collect data. So you do have a sensor, but you have to go physically and tell the sensor the kind of parameters that you want so that you're able to get that data. If you look at that kind of system, that used to have a lot of inefficiency because it meant that a human being had to go physically to a system, look at what kind of parameters do I need, and all that is time consuming. So with the introduction of IoT, we've now been able to have increased operational efficiency in how we collect data from different environments. And I think as we know, human beings, we are inherently lazy in nature. If there's something that we're able to get or collect anything remotely or automate, that is one of the fastest way that we are going to uptake technology, ensuring that you're able to collect data without me being at the said location. And then we have cost reduction. If you look at cost reduction, this is basically, if you look at the human workforce, think of it this way: as someone who is going to collect data from a very far away distance. Let's say you are doing meteorological data.
Excuse me, guys. Am I the one who has only lost audio?
I think he's dropped off. Maybe he's had a challenge. So let's just be patient.
Sorry, guys. I lost the connection.
Okay, well, welcome back.
Yeah, thank you. So I was talking about the cost reduction. Think of it as if you are moving from one town to another, one location to another, there's that time being consumed before you collect that data. Yeah. And that means you're incurring a lot of costs and you'll be getting data that is let's say a few days or a few hours late, which is not really real time. So IoT comes and solves that gap whereby you're able to get your data real time, depending on the parameters that you're going to configure. If you want to get data within 10 minutes, you should be able to get that. If it's every minute, you should be able to get that data. Then you're able now to do improved decision making. And the whole point you're able to do decision making that is quite improved is you'll be making decisions based on data that has been analyzed. You have some insights that will give you a better way of making decisions. If it's about looking at food security, you're able to tell that this location, they have this amount of rainfall. This is the kind of crop that they need. And yeah, I see. So your decisions are going to be data driven because you're able to get real-time data and make decisions in real time. And then you have enhanced convenience for users. As I said, we are lazy as human beings. And if you're able to get anything that is convenient for us, we should be able to uptake that technology as soon as possible. And that is where IoT comes in also. It ensures that you as a person, you're able to do other tasks, knowing that the system is going to be looking at the critical aspects of your environment without you being physically there. So inherently, you have a way of having that convenience that if I am in my house, if I'm at work and I have something in my house that is not going right, you're able to tell that, yeah, there's something that is going wrong. I can ask someone to attend to that as soon as possible. So those are some of the benefits of IoT. Are those, I think, there's a slide I will share also about that explains this much better. So as in any technology, as much as you look at the challenge at the benefits, there'll always be challenges. And these challenges, especially in IoT, will come owing to technology. As you know, right now, people are big on big data and data protection. So one of the risks that I have encountered personally is to do with privacy of data. And this is because you do a system in an organization, and the thing that you're asked about is this data that we are collecting. Who is able to access this data? Yeah, even if the data is in its raw form, as you're sending it to the cloud, who is going to be accessing that data while it's on the cloud, after it has been analyzed, or even when you're looking at the dashboard for your application? So this, especially right now when we're having the data protection and the likes, it's something that people try to work on, and ensuring that you have security measures on how to encrypt that data that is being transmitted, and also ensuring that the organization that owns the data is the one who is solely able to access and distribute that kind of data being collected from the sensors. The other challenge that we have is security risks. Remember, the internet nowadays is everywhere, and the devices that we are connecting are accessing the internet. And this gives an opportunity to hackers and anyone who is online that is malicious, that is able to, let's say, get that data while it's in transit. So it means that your technical skills and your cyber security awareness should be quite high so that you're able to mitigate against this kind of risks. And that translates to increase in costs. Remember, I mentioned about cutting of costs during implementation of data collection. But in this case, the kind of costs that come with it, especially security, is quite high. But what has happened is most of the security risks are usually handled by the technical people, so that the end user, does not really have that challenge of thinking about the security of the end device. So the people who are going to be managing the infrastructure are the ones who look at the security risks mostly, and try and advise and take that burden away from the end user. And then we have data management. Data management, this will mean you have a lot more processing power. You have a lot of storage space. And this is because of the amount of raw data that is going to be collected and analyzed. There are some sensors that send data that is so intensive, such that especially the people who collect, let's say, soil. It's called soil what? Yeah, the thing with soil. One sensor is able to send a lot of data. So that looks at, you need to have very good connectivity to the sensor. You need to have very good connectivity to the cloud service providers. And then the storage of that data, because it's a lot of data, you get a lot of petabytes of data. You have petabytes of data that needs to be analyzed. You need somewhere to store that data. So that means you have to scale up your data centers. You have to scale up all that infrastructure that is going to handle that data. And then for the analysis, you need to have a lot more computing resources, which is quite expensive. And that is the reason why you have all these high performance computing people. You have Google doing all their computing and processing power. You have Amazon doing it. And that's why they charge a lot. Yeah. With time, the costs really run up if you are doing a lot of analysis. But with time, as anything is, because this is something that is quite new, with time and then looking at the economies of scale, that price is going to come down eventually. But as of now, we have that challenge. If you have very many sensors that are collecting data and sending that data somewhere, the devices or the infrastructure that is going to be receiving that data is going to be really upscaled in huge proportions. And then there's interoperability issues. What we mean by interoperability is you have devices made by, let's say, different vendors. You have Huawei have their own devices. You have Cisco who have their own devices. You have IBM who have their own devices. You have HP. So all these vendors, integration of the different vendors to one platform seamlessly is really a challenge. In some cases, you have people who only have sensors that communicate only to their platforms. Let's say if you have a Cisco sensor, it can only communicate to a Cisco platform and not to a Huawei platform. So those kind of challenges are there. I know there are standards that are being developed just to ensure that there's openness and interoperability by the IEEE. And with time, I think that we should be able to alleviate this problem. But as it is right now, in some cases, you might have devices that are not able to communicate to different vendors. So there are these technologies. I'll go back two slides before I come to this, so that we are in the same aspect. I'd like us to look at the thing and the gateway. This is where I'm going to be talking about the technologies right now, between the thing, the gateway, and also the cloud. So we have different technologies. I'm sure all of us are familiar with Wi-Fi. This is the normal wireless that we refer to wireless or Wi-Fi. And then we have Bluetooth. I think we all know Bluetooth. I don't think anyone doing computer science work. We have 4G, and now we're moving on to 5G and other emerging technologies in 5G. So these are the traditional ways of connecting the device to the gateway: Wi-Fi, Bluetooth, and the cellular network. We have two other networks that are called LoRa and Sigfox. So each of these has its own advantages and disadvantages that I'll explore in the next session about the technologies. All of these are wireless. So we have a general term called the wireless sensor networks that caters for all these technologies that run IoT. The only difference is the kind of frequencies that each run on. So Wi-Fi has different frequencies, 2.4 and 5 gigahertz. Bluetooth is also in the 2.4 gigahertz. And then you have cellular that is within the 900 megahertz range. And then you have the LoRa and the Sigfox. Now, most of the IoT companies prefer to run cellular, LoRa, or Sigfox. And this is because of the amount of coverage and distance that the sensor is able to be deployed away from the gateway. These distances can range up to 100 kilometers from a single gateway. And as such, most of these IoT devices, especially that are deployed on wide scale, tend to look at the cellular network, because of its wide coverage. We have the LoRa, which is also another technology for IoT. And then we have Sigfox. Now, in this, the two, we have the cellular network and Sigfox. Those ones are proprietary, meaning that you can only run them by talking to the owner of that technology. So if you are running a cellular network, that means your sensor or the end device must be able to communicate to either the mobile network operators, the Safaricom, Telcom, Airtel. That means you need to have an additional investment of a SIM card that is able to communicate to these networks. We have Sigfox. Sigfox is also proprietary. If you have a sensor, it has to be Sigfox compliant. And for Sigfox, they are a bit difficult to deal with because they only have like one provider per region. So you'll have even to buy devices from that appointed partner or vendor. And then you have LoRa. LoRa is now the open source version of Sigfox, whereby anyone with any sensor is able to connect their sensors or devices to a gateway that is running LoRa, and they're able to connect to the cloud and do an analysis and later do a dashboard that they're able to look at the kind of data that is being collected to make informed decisions. So this depiction is how things are connected in some of the applications that we can run through. So you have the Internet of Things cloud, and you have IoT-enabled factories, you have shops. When we say IoT-enabled, it means there are devices within that particular building or organization or institution that is able to communicate to the cloud and to the Internet of Things based on the technologies that I have highlighted here. So each of these organizations must be running these technologies. Without this, you'll not be able to do Internet of Things. So if you look at, you have mobile devices, you have homes, you have cities, you have even planes and ships that communicate with this. All this will communicate using the technologies that I have mentioned earlier. This one is a depiction from one of our clients who runs a conservancy, and they run a sensor network that monitors all these aspects. They have ranger tracking. This is so that they're able to know at any one time where their ranger is. So in their mobile devices, those are IoT enabled. In their vehicles, once they're moving around tracking animals and the likes, also their vehicles have some IoT devices in them. You have fire alarms. These ones will be triggered and communicate back to the control room that there's a fire at a particular place. So they have mapped the whole conservancy such that if anyone breaches the fence, or let's say there is an elephant has crossed, there'll be an alert that this fence has been broken and they're able to come and repair. Because remember, they're all electric, so they have a way of knowing and pinpointing the exact location where the fault is. And then they track the rhinos because they're endangered. So they have tags that are IoT enabled, and they're able to look at these from their control room. And also they're able to count and tell how the population of the rhinos that they do have. Then elephants, cheetahs, these ones look at the migration patterns of all these animals. And then livestock tracking, because they also work with local communities. So they try and look at the livestock coming from the neighboring communities within. How many are getting into the conservancy? How many have been eaten by lions and the likes? And this way they're able to mitigate against the human-wildlife conflict because of that. Then just environment, resource tracking, and then reporting and verification. This one is very important for them because with the data that they collect, now they're able to say, within this conservancy, we have X number of animals. These are the number of rhinos. These are the number of elephants. We have this number of rangers. Our rangers move from here to here. These are the migration patterns and the like. So that way they're able to make informed decisions on where to deploy. If they're deploying rangers, if there's a migration pattern that they want people to meet at a certain point so that they get the best view of the livestock. So those kind of things, they're able to adjust because of having IoT. So further applications. These ones, I think there are so many, but I'll just highlight a few that that we're able to run through in, let's say in our day-to-day lives. So we have smart homes and offices. So what you can potentially monitor in your home, you can check the air quality in your house. If you have developed, if you have built anything or you're renting something and probably the air circulation is not good, you have sensors that are able to tell you that you need to do something. If it's in the office, you have employees who are complaining that their offices are quite hot, or there's something in the air that they feel is affecting them. You're able to tell that in a minute's notice if there's anything that has changed. You can also look at leak detections. This is if you have gas leakage in your house or in your establishment, you're able to do that. Remote control of lighting systems and security cameras. So in this case, you might be thinking about conserving energy in a building. And when most people are leaving the building, they tend to forget to switch off the lights, and your power bills are escalating through the roof. If you're able to do an IoT system that detects someone has left the building and it turns off the lights, and when someone walks in, the lights are turned on, so that the lights only come on when there's activity or when that particular room is being used. And if no one is within that particular vicinity, the lights are off. You find that your power bills are now going to come down. Let's say you have cooking equipment within the office or in your house. If it's IoT enabled, you could do whatever you want with it. Think of it this way: if you have a microwave in the house, let's say, You leave in the morning, you put a plate of food in the microwave, and when you leave work in the evening, you're able to instruct the microwave to start warming, or the oven to start cooking or something. This goes to the point where I was saying humans are lazy. If you're able to have it do something without you telling it physically, you go to microwave and start bonyezaing. Something that you look at as an application of IoT also. Security cameras, these ones, as I mentioned also in the conservancy, they are motion-enabled IoT cameras such that if anything passes by, there's a trigger. And that trigger is what is communicated back as data to the control room and you're able to tell that something has happened within this region. You can apply this also in the house or in the office if there is a certain restricted area whereby a certain face is not supposed to be there. It is an alarm. If it is a place you're monitoring students, let's say, and there's some funny business going on, you're able to get an alert and respond accordingly. So the other application that people might look at is healthcare and digital medicine. And this is patient health tracking. One of our members, they're called Empath. So they employ this very much to track their patients. They have an application that their patients install, and then it's able to give them movement patterns. The checkups, they're able to tell that this patient was supposed to come for a checkup at this particular point in time, and they have not showed up. So the medics and the clinical officers are able to contact either the family or whoever, the guardians, about that particular issue. They're saying, yeah, the patient so-and-so has not come and they needed to have, let's say, some medication or some dialysis and they've not showed up. So they're able to follow patients and just to improve the healthcare. The other thing is they're like the diabetics who probably need like the continuous glucose monitoring. They have those patches that IoT enabled. And whenever there is a spike in their sugar levels, they're able to get an alert and know that, yeah, it's time to do my insulin, and just a way of early detection in case there's a potential problem. So wearable health monitors, I think nowadays we all have smartwatches, and we all monitor our steps. Yeah. There are those pacemakers that people use. Those are all IoT enabled because they all send some signal to a central server and then alerting someone that, yeah, your heart rate has gone too high. You need to slow down. And then there is real-time data for medical equipment. This is so that they're able to look at failure rate of equipment. If it's a CT scan machine that needs maintenance, they're able to get alerts. If there's a failing component in one of the machines, they're able to attend to that very fast. And for hospitals, actually, IoT has been one of the biggest changes that they've had to adjust to, just to ensure that doctors and the medics are able to respond to problems in a timely fashion. So another application is smart cities. We are all dreaming of having everything working efficiently within a city. And this is something that most of our leaders should be able to try and appreciate, especially in terms of traffic management. We have a lot of traffic snarl-ups, and if we had some intelligent traffic lights that are able to sense that this side has a lot of traffic, let's send an alert to, let's say, the traffic police or the traffic department, and they're able to deploy traffic marshals. Alternatively, if you have an IoT system that is able to look at the traffic congestion and reroute traffic depending on the traffic lights, those are some of the applications that IoT is able to take. And then you have smart street lights. If this is able to be implemented within a city, such that you look at the time of day, the lights are able to come on and off. Look at the intensity of the light, of the street lights. Let's say probably a street light goes off and there's a dark patch. The neighboring street lights are able to increase the intensity and then send an alert to the relative authorities that this particular side of the street has a failure on one of the street lights, and someone is able to come and repair that. So, and then going back to also environmental monitoring, this will just look at pollution mostly. If you have noise pollution, you have a sensor that says someone has violated this critical decibel on the noise threshold. Yeah, send someone to go and arrest those people, or tell them to tone it down. So as a way of just ensuring you have a lean workforce, you have good data. You need to know if I want to avoid or implement policies that are going to be touching on specific aspects of the society. Do I have data to support those policies? So that is where IoT also comes in. Yeah, this was supposed to be farming, not, this is agriculture. I was looking at agriculture also. This was precision farming. Precision farming, this is if you want to have to look at the amount of moisture in the soil, you want to look at how the amount of humidity within a particular region. You're able to put in sensors that will be able to tell the farmers or the food people that we need to do planting in a certain period. We need to be watering our crops in a certain manner, or there's an excess of water in the soil or the likes. So that we're able to make informed decisions on the kind of farming that you want to do at a particular time. For smart irrigation, this is looking at the moisture content and at what times of the day do you need to do irrigation to your crops, or at what times of the year is it optimal to do irrigation. And then livestock monitoring, this is just looking at the health of your livestock. Let's say you have 2 cows, give them a tag that is IoT enabled and that is able to look at the parameters. Probably the animal needs some immediate attention. You're able to get an alert on that. Even if you're not looking at the animal, you're able to get an alert and go and attend to it. So these are just some of the use cases. There are a myriad of use cases of IoT, and it's up to you to decide what what can I do with it? The possibilities are endless. If you own a car, you are able to do something. Let's say there's a component that is failing, and you're able to get a part without you knowing. I think there's one scenario we encountered from one of our partners, and this was with the Audi group in one of the European countries. You get a text on your mobile phone telling you that you need to go and collect this part from this particular garage. You had no idea that that component was failing, but you get a text telling you that this part was failing and we have sent you another replacement. So just go and pick it. So you can see how that makes life easier. So I've been talking about sensors, things, and devices. So these are just some of the few sensors that you can look at. Temperature sensors. This one will just measure what is the temperature within a particular room, establishment, and what kind of action to take. And so the way this happens is you can configure applications that are able to do countless things. Let's say the temperature rises. Do I need to shut down a machine? Do I need to open the windows? Do I need to start the AC? Do I need anything that you're able to do just from that one sensor? You're able to do so many things just from the reading of a particular sensor. You have humidity sensors, proximity sensors, motion sensors, light sensors. All these should be able to be integrated to any kind of IoT system to give a whole solution, and hence the concept of having smart cities around, or smart offices, smart hospitals. Anything that they say is smart is not only being paperless, but looking at what am I going to do with the data that I have collected, and how am I going to improve it for the betterment of the society. So I think as you look at the IoT technology, you can now start conceptualizing the kind of applications and the vast implications that you might be able to achieve using IoT. That is very different from the traditional projects where you do something and that's the end of it. IoT, because this is the Internet of Things, it's connected, and by anything being connected means that you are able to have unique solutions that have an impact to the society. And if you look at it, can be monetized. So as part of what we look at in industry is the kind of solution that I'm going to be offering to a potential client. Does it encompass all those aspects? Is it what they need, first of all? Is there any improvement that I can make to them? And is it going to put money in my pocket? So once you look at that kind of implementation, it's the possibilities are endless. And I would like to encourage you that as you go through this journey, do not be limited by what I have talked here. This is just a subset of what IoT is able to do. And remember, IoT is everything. Even if I have my phone here, I have my watch, my smartwatch, I have my pacemaker, I have my temperature sensors. So it moves from just being from an individual to an establishment to a global perspective. Yes. So now this is what I was talking about. Why we need to have the cloud servers. So this is a project that we are running on food security. We have some sensors installed in different locations that reads different parameters. So we have a sensor that reads the temperature. We have a sensor that reads the wind speed. We have a sensor that reads the amount of rainfall on the wind gauge. And we have another sensor that reads the pressure. So we have a rain gauge, we have an anemometer, we have a barometer, and something else. Now, if you look at, I'm not sure how visible this is, but you could see there is scheduled data downlink, and then there is forward uplink message. So this is the kind of message or the kind of communication that happens between the gateway and the device, which is the sensor. So the sensor will send the data, yeah, and then the gateway will receive that data and push it to the cloud. So this is the kind of data. As you can see, you're not able to tell what this is exactly. But now there's an application that reads this data. Oh, there's an application that analyzes this data, and then there's an interface that now you're able to read this data and make sense of it. So just going into, yeah, this is one of the packets. Now looking at the raw data, looking at the packets that is being sent from the device. So when you look at, there's something called a device ID. This, for each device, you have a unique ID. It's like a fingerprint that cannot be assigned to any other device. So we have an endless amount of devices in the Internet of Things ecosystem, and each has its own unique identifier. So even if you have 20 sensors from the same manufacturer, they all look the same, they have the same color, embedded within the sensor is a unique identifier. And the whole reason this is you're able to tell that the data I'm receiving from this particular sensor is real-time, it's accurate, and is trustworthy. And if anything changes from that, you're able to get the corresponding changes in the upstream. So once you have this data, I know you're computer scientists and data analysts, so that is what this is what you read, and then create an application that is able to give this information to me as a user who has no idea what happens in the background. Because as a user, what I need to see is my house closed or not. I don't need to know if the contact sensors are, how they work, and and the technology behind it. I just need to know, open the door, close the door. But behind that command that close this door, this is the kind of data that transverses that whole ecosystem up to from the device all the way to the user interface. Yes, so and in conclusion, for this session, it's just a way of telling you that IoT is able to transform your day-to-day lives, and the possibilities are endless. You can do anything that you want because we have billions and billions of devices. We have enough resources to handle that amount of devices. We have so many people with great ideas, and the only limit that we might have is thinking, that we cannot do it. So despite challenges, as I've talked about, we have the privacy issues, the security issues, the interoperability issues. IoT is able to make our lives much, much easier and way more efficient in running our organizations or even our personal lives. Yes, I think that is the end of the presentation for now, and I think this is just an introduction on IoT. The next session I might go deep how it operates, so that you get to understand the behind the scenes in a deeper perspective as compared to this. This is just giving you a holistic view of the applications that you're able to do with IoT, the technology behind it, and what IoT is, just as an introduction. And then now we should be able to discuss more on this. Thank you very much. Any questions?
Yes, Bryson, go ahead.
Oh, okay. So you mentioned when you're considering IoT, maybe projects you want to do, you should consider what puts money in your pocket, right?
Yeah.
So what puts the most money in your pocket? What areas?
Personally or the organization?
Just generally or even personally.
So as for let me handle it from the organization perspective. As I've said, Kenneth, we support the higher education and research communities in Kenya, and mostly with research, they are so high on data. So what we try and do is give them an avenue on how to collect their data, how to improve their research. You get it, so that when they publish that data, they are able to look at, they have assisted what do you call, the community on doing 1, 2, 3, 4. And then as an organization, because we get our revenues from primarily giving connectivity and research services to this kind of community, we leverage on that kind of subscription. So they subscribe, and then any other services that we have, we now push to the members. But first, we get our money from most of the subscription, and that is because our mandate is just to facilitate higher education and research. So what I will look at is the researcher. Is the researcher able to achieve the end goal, whether it's monetary or research-wise? And then I am now the facilitator within that whole transaction. Does that make sense?
Yeah.
Yes.
So Edwin, I see your message on the chat. So which project, is this your 4th year project or the project for this course unit? Edwin. You're unable to talk? Okay, so Achiki,
Okay.
I think,
Yes.
yeah, you can see his message. What do you mean the school has taken it up? Okay, you type a full message because I think we are not able to understand what you're saying. So any other questions? Okay. Yes, Terry?
So the chairman of our department, Dr. Kahonge, told me that Kenneth offers high computing services, for people, maybe students, for example, students maybe whose projects need a lot of high computing power. But then he told me that there was a process in which you apply to be able to leverage such services. How do we go about it?
Yeah, so that will just be just dropping an email to us, and then someone from our team, there's a lady called Joy who does the research infrastructure, should be able to connect you with that. But we do have that kind of facility for students, researchers, faculty, anyone who is within the Kenneth ecosystem. We should be able to do that. So all you just need to do is just communicate to us via email, and then that should be okay. The email is just, I think I should type it here.
Yeah, kindly type so that they're able to know where to send the email. Actually, thank you so much, Terry, for that. I was going to highlight that because, like even last year, the students, especially you're doing machine learning or LLMs, or even an IoT project where you need a lot of data, then or compute power, rather than struggling to complete your project on your laptop, you can request for a virtual machine from Kenneth. So make sure you take advantage of those facilities. Okay, so any other question? Oh, sorry, there's one from Duck. So Achik, you can see the chat. There's a question for you there.
Yeah, I can see specific language. I think if you're a computer scientist, you should be able to do in any language, but I think Python mostly. I have done mostly on Python. I am an electrical engineer by profession, so yeah, I don't do a lot of coding, but Python should work fine.
Okay, so I think there are no further questions. So I think, okay, yes, Bryson?
Yeah, I have another question.
Okay.
When you're, let's say you want to solve a problem, how do you stop yourself from solving problems that have already been solved in even simpler ways? I'll give an example what I'm talking about. So there are these guys who created a smart water bottle. So the idea was that it tracks how much water you're drinking, and even if you're not drunk enough water like today, it's supposed to send you a notification on your phone, like you're not drinking enough water or something like that. But really, afterwards, people came to realize, like, what if you just use a different water bottle? Do you have to keep updating on your phone that I drank this much water so that it knows and reminds you or something like that? And, and then the bottle didn't actually sell at all. So, yeah.
Yeah, so the niche here would be, do not look at reinventing the wheel. Think of how you're going to improve. Because most of the issues that we have seen around in industry is people try and you don't do enough research. You begin a project. You have not looked at if it has been done anywhere else. And then, you find you are doing the same thing that someone else has done. Rather than improving it, you do the same thing. So basically, you are inventing the wheel. What I will advise is you first, before you begin any project, look at what gap am I going to fill. Even if it is that water bottle, what gap is there apart from just looking at me alerting you or looking at the water level? What else am I able to do to fill a gap that is because there's a gap? There's always a gap that you're able to fill with that. But the whole point is, please don't try and reinvent the wheel, because if you, it's not an original idea, and there'll always be someone who is better than you who has done it, and someone who has more financial muscle. So the whole point is, think outside the box, do enough research, and look at the gap that you want to fill. And that you should be able to find your niche.
Okay, thanks, Cornel, Chiki. So, Bryson, I think you asked a very good question. I wanted to chip in on that. What you've raised is, and I think Achiki has answered it very well, there's something called identifying a need. You know, that if you want to do something innovative, you must be solving a need for a specific group of users. Yeah. So if you're driven by using technology and looking for a problem that the technology can solve, you may miss the mark. And maybe that example of the smart water bottle was it, oh, we have IoT, we're able to do this. But maybe nobody needed that, you know? So don't let your solution be driven by the technology. Let your innovation stem from a need that you've established from a certain group of users. And that's why I keep saying it's so important for us to really understand what are the problems around us and who cares about those problems, what value would you be adding in solving them. Now you come to the next step, you ask, what is the best way to solve this? Is it IoT? Yes or no? Is it AI? Some things you don't need a hammer to. You know that's saying you don't need to use a hammer to kill a fly or something like that. So let's have, I think Terry, I'd seen your hand up, and then Edwin.
Yeah, on the sending an email for high computing, do you maybe like need a letter from the department to prove that you're a student?
I think
all
what
that
you need to do, of course, you use your university email address, and then you CC your supervisor. It's always good to have a lecturer in copy, so that if they need to validate anything, that there is that extra input.
Yeah,
Okay,
that's correct.
Yeah, also you could also CC me because I also support Kenneth. So in fact, it might be better just CC me as well, because I'm able to fast track where you're stuck.
Okay.
All right, then Edwin.
Hello, thank you for taking time to speak to us. This lesson has been very insightful. I've learned a lot of things today. I actually thought IoT was just some gimmicking thing, but I learned that IoT is really a crucial aspect in technology. So my question is, there's something I've been really following up in how it is done in America, and I've been wondering how it has never been implemented anywhere in Africa. When you go to America, I don't know if you guys are getting me.
Yeah, we're
Yes,
getting
we
you.
can.
So when you go to America, there is a company called, I don't know if it's called Bison or something Zen, whereby all the security enforcement, they walk around with cameras, body cameras, and anytime there's a criminal offense or something that needs a police officer to be there, anytime they go to court, maybe to prosecute somebody who participated in crime, one of the things that is required is a footage of the arrest or how the officer responded. What I've seen similar to that is there are cameras in locks in some crime offices. So I was just wondering, the Kenya police, has nobody thought of implementing such a thing maybe in Kenya? Because we have a lot of issues with the unlawful arrests and things like those.
Where? That one?
I think you can tell Edwin he can be on to implement it. You have seen a gap. Why don't you cobble up a nice solution, Edwin?
I'm just wondering because you see, this technology has been there for quite some time. I'm just trying to figure out because Cornelius has been in the industry for some time. Maybe he can tell us if the resistance maybe from the government, or is there an opportunity for such a initiative?
I think what I would say is in most technologies, any new technology, there's always that resistance to change and acceptance. In our case, I think we know our case is mostly acceptance. No one will accept to move around with a camera, and they're going to do something that is not within the law. So I think that one stems from the top. There has to be buy-in from the top, and then scales down all the way to the police officers. And it's something that is a Kenyan problem. It's not just within the police. It's a Kenyan problem, because most of the solutions that we also try and give people, there is that resistance from the top management. Despite them seeing the value proposition, there'll just be someone who will be like, no, we don't need that one, because they know it's going to plug in a loophole that they are trying to exploit. So, but I think with time, we just do what we can. For those who accept, you work with the ones who accept, and then hopefully that scales to, or it becomes infectious to the other larger population. I think there was someone who was 3D printing services. Yeah, there's Gearbox, and then I think there was Fab. I don't know if Fab Lab still exists, but Gearbox should be okay. Thank Dr. Gashigi. It's Dr. Kamau or Dr. Gashigi? That one.
Yeah, those are both his names, Kamau Gashigi.
Yeah, I think Gearbox should be okay.
Okay, I think we can wrap this up if there are no other questions. So I think from what Achiki has said, the next session will be now the really hands-on. I know there are some of you who are itching to go with your projects. And today I had a meeting with some Huawei guys, and they've agreed to give us some IoT kits. So I will push to see how many we can get, and the teams that wanted to do an IoT project, probably you'll have some kits that I think they said each of them comes with like 8 sensors. What we don't know at this point in time is whether they're open, or probably they'll have to use Huawei technology, which is also not a problem either. I thought by now I'd be seeing some good likes and claps. You're working day and night to support you guys, and you're not even appreciating what we're doing. Thank you. Yeah, so I'll keep you posted on that. So let's also appreciate Achiki. He's a very experienced engineer from Kennet. Maybe most of you may or may not have heard of Kennet, but now you know they do more than just provide internet. That's the internet we rely on at the university, and actually all universities use the Kennet infrastructure for internet. And what Terry asks, it's very important. They also have virtualization services, so you can get a VM assigned to you. They already come with certain appliances already installed. For instance, if you're using TensorFlow, you don't have to struggle to install. You just request and you get a VM already that's pre-configured with everything that you need. So I think for your 4th year projects, as well as this particular unit, you should really take a look at what that's available for you, because it allows you to do a meaningful project, especially it's data or compute intensive. So thank you so much, Achiki, for your time. We don't take it for granted, and we're looking forward to the next session. So guys, thank you also for being very accommodating. Today you've had a long day. Next week, I think we are going to have the LLM sessions, and then the final session with Nanda on the containerization, and also the final session on IoT. Then from there, you will choose your projects, form groups, and you get started. Okay. So happy Friday. Go and enjoy yourselves.
Okay. Thank you very much. Thank you, team.
Mm.
And
Thank you.
Thank you.
yeah,
Thanks.
see, there was someone who had raised their hand when we were done.
I'm wondering, Hashim is the class rep. Hashim, what did you want to do? Did you have
Hi.
a question?